Okay, I wanted to make a quick video talking about the absorption lab third question because I feel like it does a good job as an example of what's probably going to be most important to all of you in this chemistry class, which is unfortunately not chemistry. A lot of you are taking what, like 1-2 quarters of chemistry? Or 3 or 4, that's great. Um, but for a lot of you watching this video or in the class, um, what really is going to be beneficial for you is just problem-solving skills, how you take problems apart, how you understand problems, whether they're chemistry problems or something else. So this question, I like to think about our problem approach kind of in just a few steps. So step one is always figuring out what's it actually asking for. So what's the problem actually asking us to figure out? What units should our last answer be in? What's the problem say?
So it says red dye number 40 has a molar absorptivity of 2.13 times 10 to the fourth and a molar mass of 496.42 grams per mole. What mass of red dye would you need to prepare 1.17 liters of an aqueous solution of red dye number 40 with an absorbance of 0.558?
Okay, I'm actually going to erase all these things that I've just wrote down. The main thing is mass of red dye. That's what the question is actually asking for. So that's the first thing. This stuff is kind of getting at part 2. And I just have the habit of writing those things down as it goes. I couldn't even stop myself, even though I knew I wanted to stop myself. Because step 2 is what's given. And we want to split this into kind of 2 categories. There's explicit information. Explicit information are the particular numbers given in the problem. So let's go through that again. You don't have to read it all, but let's just get the numbers that are given. We're given epsilon.
Yeah, it's 2.13 times 10 to the fourth.
What else are we given?
The molar mass, 496.42 grams per mole. We need to prepare 1.17 liters. It has an absorbance of 0.558.
Right? The explicit information is easy to get because it's just given to you. But every problem, the trick of every problem is not the explicit information, it's the implicit information. Right? The implicit information is the things that aren't said in the problem that you're supposed to figure out. Right? Every question that you're asked in pretty much any class is really asking about the implicit information. What connections, given this information, what connections can you make? Now there's a few things that we should be able to spot right away. If we're given epsilon and we're given absorbance, whose equation are we going to use? What's the only equation that we've used in that? Yeah, Beer's law, right? So implied inside of this is going to be Beer's law. Right? Also the context of the problem, the fact that it says it's a red dye and that we've got an absorbance, we're making a solution. All of that stuff should suggest Beer's law to us. Notice I don't think it gave us a path length. Assume a path length of 1 centimeter, as we usually do with Beer's law. If it doesn't give us like a specific other thing, but again, that's implicit information. Right? It's not given, but that's something you have to assume to do the problem. It's a little bit different than implicit information because that's assumed information. Slight difference. But again, it's about figuring out where the holes in the explicit information are. That's every question you're asked pretty much your entire college career is going to be this type of structure until you get to your upper division classes where you're trying to make up new things. So this is how we're going to use epsilon and A. Beer's law, we assume the L. That's going to get us some concentration.
Isn't the epsilon to the fourth Or at least mine.
Oh,
Fourth, not
yeah,
third.
sorry. I just wrote that totally wrong. It should be 10 to the 4th. I was just writing too fast.
Okay.
Yeah. Now, also important thing to point out for those of you looking at your lab pal assignment, you're going to have different numbers because it randomly generates numbers for you. So that's one of the fun things about lab pal. But the same conceptual understanding still works. So we know we're going to be using Beer's law. That's going to get us to some concentration. What other things are we going to need in order to solve this problem? What do we do with concentration? And what explicit information?
We could use the M1.
Yeah!
M1, V1, M2, V2.
We don't even need that much. We can just do molarity times volume equals moles. Right? Using this volume, we can say, look, molarity times volume equals a number of moles. So that's going to give us, from this absorption with that molar absorptivity, we can get a concentration. That concentration is going to be our molarity times the volume is going to give us moles. And then there's only one more piece of information we need to use. There's one more implicit thing.
Converting moles to grams.
Molecular weight times moles equals grams. Right? These three things, not specifically anywhere in the problem. It's all just implied. It's things that you have to figure out from the context of the problem, from your knowledge of the course material. And most questions are trying to look at you, how well can you figure out that implicit information? After that, we've got step 3, which is solve. Right? That's the last thing we always do, is we solve the problem. So, I'll go ahead and post this to help out anyone else who's stuck on that problem, but you can apply this kind of thinking of what's it asking for, what's given, and how do you solve to almost any problem on the homework, most problems in the unit conversion quizzes, all of those things kind of can be broken down in this kind of thinking.